In this video, I'd like to talk more about congruent triangles, and specifically take a look at the side-side-side congruence rule or postulate. And what this essentially means is that if you have two triangles and you can show that they have three sets of equal sides. So let's say that AB and DE are equal. We can say that BC and FE are equal to each other. And we can say that AC and DF are equal to each other. Then we can write that triangle ABC is congruent to triangle DEF. And remember that the way you write out the names of the triangles matter. The corresponding side lengths have to match up. So AB and DE have to be written first, BC and EF written second, since they are equal. And notice that if you combine A and C and D and F, that they're in the correct order since they are equal to each other. So the ordering of how you write congruence, that two triangles are congruent to each other, matters. And the side-side-side rule essentially states that if the triangles have three sets of equal sides, then you don't need to know anything else. You can prove that the two triangles are equal to each other. And there are a couple ways we can look at this. One way is to accept it as a postulate, something that we assume is true. And we can understand why this has to be true based on our intuition. We can draw pictures to make sense of this. Or an alternate approach that was taken by Euclid, who is known as the father of geometry. In his book, The Elements, which was written about 2,300 years ago in 300 BC, this book actually proves this as a theorem. And remember, a theorem is just something in math that is proven true. So it is possible to prove this relationship, this congruence rule, from basic principles. But in modern geometry, it can also be taken as an axiom or a postulate, something that we assume to be true. And again, it does make perfect sense that this is true. And let me make a little bit of room so that we can think about this and why this might be a postulate. If we start with three different side lengths, then what we can see is that there's only one triangle that can be formed out of this. So these three side lengths, first of all, they have to be side lengths that can actually form a triangle. We can't have two small legs and one huge leg since those won't connect to a triangle. But if we assume that the three sides are long enough to form a triangle, we can draw one leg and then imagine putting points here where you can rotate the lines in either direction. So you can imagine if we rotate this line in and we rotate this line in, that they're going to meet eventually at a point. And let me draw that in, and this will be a little bit difficult to eyeball, but we can imagine that these two lines are going to meet at some point. And there's only one point that they can meet at. And likewise, if we rotated them in the other direction, they would also only be able to meet in one specific way. And in this case, it will be the exact same triangle, but reflected over this line here. And this is not drawn perfectly, but you can at least imagine what's happening. You start with a line in the middle that's connected to your two other sides of the triangle. And you can imagine these as being hinges where you can rotate it about that point. And if you rotate them both upwards, they'll form one specific triangle. There's no other triangle that can be formed. And if you rotate them downwards, they will again only form one specific triangle. And in fact, this triangle and the one above it, those are the exact same triangles. And one way you can verify for this for yourself is to find three objects that can be represented as lines, maybe three different size pencils, and form a triangle with them. And what you'll see is that there is only one possible triangle that can actually be formed. Or maybe you find three different sticks that are all relatively straight and of different lengths. And if you try to make a triangle from those sticks, there is only one triangle that you can possibly make. There is no other way to combine them to make a different triangle. Or, in other words, the triangle might be at a different orientation. It might be, let's say, rotated or reflected or translated, but that's okay because the triangle will have the same shape and the same size and will therefore be congruent. So, as an example, we can look at this problem here where we have two triangles shown below, and we need to determine if they're congruent. And what you can see is that they each share this long side of 6, they each share this middle length side of 4, and they each share this short side of 3. And since they have three sets of equal sides, by the side 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 rule or the side 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 postulate, we can confirm that these two triangles are in fact congruent to each other. So, in summary, if they share three sets of equal sides, then the two triangles are the same size and the same shape.